We are still going to look into another one. Let's look for another past question. Another past question. Alright. Now look at this one. Look at this one. This is another past question. This is another past question. We draw a circle, that's number 3. We have a circle, we have a circle. Then this is our R, and this is a R, S, P. I think I'm not that. This is alright. What happened here? We have let's do this again. We have this one joining this place. This one joining this place. Okay, we have it like that. So this angle is 8x, and we have center O, and our angle here is x. Now the question says the diagram is a circle with center O. It's a circle with center O. Then we have P, R, S, T are points on the circle. They are points on the circle. Find the value of angle P, R, S. Find the value of angle P, R, S. Okay, there's a point here. We have a point here. This is called point T. Point P, P, R, S, T. Okay, this is a question again. Under circle theorem, you can see that we are looking for the value of P, R, S. We are looking for the value of P, R, S. So what's going to be the value of P, R, S? We are looking for the real value. We have to find the real value of X. And if you look at the question, they've not given us any value in the question at all. But there is a way of getting the real value. Now, we are going to combine two theorems together in this question. Because without working with two theorems, you cannot get any value that you are looking for. So the first theorem is what I have explained to you earlier on. The first theorem that I have explained to you earlier on is that angle at center is equals to 2 multiplied by the 1 at the circumference. If you look at it now, which one is angle at center? The angle at center is a POS. POS is angle at center equals to 2 multiplied by PRS. PRS, that is angle at circumference. The reason is that angle at center is equal to twice the one at where circumference is twice the one at circumference. That's the first theorem that I've proved to you. Like I've told you, circle theorem is involved once you can identify those theorems very well, once you can understand the theorems very well, the one says angle at center multiplied by the one at the circumference by 2 will give you the angle at center. The other one says opposite cyclic quadrilaterals are equal. Another one says angle at the segment of a circle are always equal. And the last one says angle in a semicircle is equal to right angle triangle. These are the theorems that will be reoccurring in calculations of a circle theorem. So once you can figure these things in your head, by the time you see it, to solve the problem will be very, very easy for you. Now look at this morning. We are given a diagram. They didn't tell us whether it is angle in a semicircle. They didn't tell us whether it is a cyclic quadrilateral or whatever. All we know is that you must find the value of a angle PRS. So what you need to do is that you examine critically which of the theorems suitable for this question. The one suitable for it is that the one at center here is our angle, our POS is 8x. So let's go by that formula now. POS is 8x equals to 2 multiplied by what? PRS, which is what we are looking for. 2 multiplied by PRS. Then what is next? What's our PRS now? 8x divided by 2 will give us PRS, which means 4x equals to PRS. That's our formula. That's our value. 4x, but that is not the real value that you have to calculate. 4x is not the real value because s is unknown. The question says we should find the real value of PRS. So the next thing is, how can we get the value of PRS? How can we get the value of PRS? It's very simple. Very simple. Well, what you can do now is look at the diagram again. Our PRS is standing here. It is opposite to this PTS. We can state it clearly that PRS is equals to PTS. PRS is equals to PTS. This is a what? Opposite angle in a cyclic quadrilateral. Opposite angle in a cyclic quadrilateral equals what? They are what? Supplementary. They are not equal, supplementary rather. They are supplementary. If they are supplementary, they are not equal. It means what we are saying here is that PRS plus PTS equals to 180. PRS plus PTS equals to 180. What is PRS? PRS is a 4x plus PTS is x equals to 180. Now we have 5x equals to 180. X now equals to 180 divided by 5, which gives us 36. The value of our x is 36. You can now see how we have used the unknown to derive known. X is equal to 46 because at top here, the angle here is opposite this one, and we said it earlier on that PRSQ is a quadrilateral. All right. Now, since PRS, we're supposed to substitute here that since, to make it clear for you, since PRST is a cyclic quadrilateral, for so in this case, if what is a cyclic quadrilateral, we say the opposite angles are equal. They are supplementary. So it means 4s, we have got our 4s here. 4s plus this x is equals to 180, which is supplementary now. Adding this one together gives us 5s equals to 180, and our s is 180 divided by 5, which is equals to 36. Now, what is the value? we have to get the real value of PRS equals to 4x. PRS equals to 4x. So we say 4 multiplied by 36, 12. That is 144 degree. 144 degree. PRS equals to 144 degree. And that's the value that we are asked to calculate from this particular question. So our value now is 144 degree. Let's look into another one. I want to look into another problem that we can solve. Alright. This one is another form of asking questions in sample theorem. Sample theorem. The question here says, in the diagram, zero is the center of the circle. 0 is the center of the circle. Radius x. Then PQ is z. PQ is z, and I think QK is y, and angle QKP is 90. QPK is 90. Find the value. You have to find the value of z in terms of x and y. In terms of x and y. In the diagram, 0 is the center of the circle. 0 is the center of the circle. Radius x. And PQ is z. QK is y. And angle QKP is 90. We are to find the value of z in terms of x and y. The diagram goes thus. This is the diagram. We have this one called QP with the center. With the center O. And we have x. When you form this one, this is y. And then we have this in the diagram. So we want to find what? We have to find the z. Where is our z? We have to find the z. QP is QP. Yes, okay, QP is z. QP. PQ. The whole lot of this one is z. So from here to here is z. So we have to find the value of z in terms of x and y. You have to find it in terms of x and y. So what are we going to do now? We have to itemize it again. This is another sample theorem in another form, and that is why you must not expect that everything will be having value. So they are now using alphabet instead of 30, 20 or whatever. They are using x, y, z and whatever. So we are going to find out something now. K. What is K? If you look at it, Okay, look at this K. This is our K. Is what? The midpoint of Q to P. Q to P. The K is the midpoint of QP. The midpoint of PQ is K. Meaning that if you want to find K to P, KP will be what? KP will be Z all over 2. Because the whole of this place is Z. If we now divide Z into 2, it means this one will be Z over 2 and this one will also be Z over 2. That's our KP. Now, if we have this one as Z over 2 and this one is Y, this is X, we can consider triangle what? OKP. Consider triangle OKP. OKP. When you consider triangle OKP, what happens? We want to find the value of Z in terms of that. So if you want to find the value of that, so let's use this way. This X is the what? Is the hypotenuse to this angle, because this one is a right angle triangle now. We have formed this one as a right angle triangle. So we have OKP is a right angle triangle. If you want to sum it up, if you want to find Z, it means the square of this one plus the square of this one will give us the square of this one. So meaning that X squared is equals to Y squared plus Z over 2 all squared. X squared is equal to Y squared plus Z squared all over 4. Okay? When you find the LCM will be 4 into 4y squared plus Z squared. Okay? Now we have X squared to be equals to 4y squared plus Z squared, everything over 4. 4x squared equals to 4y squared plus Z squared. Okay? Now, we want to find the value of what? Z in terms of. You will recall that we have done half of what was given to us there. Because we are looking for Z in terms of everything. So in this case, our Z will be what? We are looking for Z. Z now, this is Z. So we are going to make Z the subject of the formula. Knowing that 4x squared equals to 4y squared plus Z squared, meaning that 4x squared minus 4y squared equals to Z squared. Then we have 4 into x squared minus y squared equals to Z squared. Z is equals to square root of 4 into x squared minus y squared. Now, what is Z now? We have, because of this power of squared, we square root both sides to remove the power. So this one becomes square root of this. Now, our Z will be, you can easily find the square root of 4. Square root of 4 is 2 into square root x squared minus y squared. This is the value of what you have to do. We have now got Z in terms of x and y. We got Z in terms of x and y. So that is another way of solving circle theorem given to us at any particular time. Now let's look at another one. Talking in terms of tangents. Let's look at another one in terms of tangents. We are looking for that one. This is another question. Let's see question number 4. We are talking of a circle, then with a tangent. We have a tangent. This is a tangent PAT. PAT is a tangent. Then there's a center. There's a center O. We have a center O. We have something like this to this place. Then this is our B. This one will come down like this. This one will go like this. We have this one as C. This is equals to this. This angle is 128 degree. This angle is 128 degree. Okay? Now, line PAT touches the circle. Line PAT touches the circle. You see that it touches the circle at what? At A. Then ACB. Where is ACB? ACB touches the circle. Okay, it touches the circle ACB. The circle is ACB. Okay? With center O. With center O. The center O at the point A. That is the place where PAT touches the circle ACB at the point A. Then the question says if AC is equals to BC and PAB equals to 128, then we have to calculate angle ABC, angle CAG. Calculate angle ABC and CAT. Okay? Now these are other forms of a circle theorem. These are other form of circle theorem. All we need to do here is to understand what the question is talking about and then solve it. There are two questions we have to solve here. We have to find ABC, and we have to find CAT. We have to find ABC and CAT. ABC and CAT. CAT. Alright. Now, how do we solve this problem? The first one is ABC. Look at where our ABC is. Let's look at where our ABC is. If you can get where our ABC is, then others is very easy for us. ABC is an isosceles triangle. ABC is an isosceles triangle. Okay? Let each of the base of isosceles, let each of the base of isosceles be y. Let each of the base of isosceles is y. The base of this isosceles is this is y, this is y. Okay? Let the base be y. Let the base be y. The base here is y, the base here is y. Because they are the base of isosceles triangle. Now, what is the next thing? We have to find ABC. ABC. How can we get our ABC now? You notice that since ABC is a triangle, It means if this one is y, the base also here will be y. Then you can ACB is another one. So we'll say y plus ACB equals to 180. Y plus ACB is equals to 180. Then what is our ACB? Our ACB will be equal to the external angle of a given triangle in this question. This external angle here is 128. You see that this 128 is not inside the triangle, it is outside the triangle. And by the circle theorem, we have been told that the triangle here is not a semicircle because this line AB is not passing through the center. So this 128 will be equal to angle C here. In other words, our ACB will be equals to 128, meaning that y plus y will give us 2y plus 128 equals to 180. 2y equals to 180 minus 128. 2y equals to 52. Okay? Then y equals to 52 all over 2, which is equals to 26 degrees. Y is equal to 26 degrees. What is y? Our ABC now, ABC is represented by y. Therefore, angle A, question A, which says we should find ABC. ABC now will be equals to 26 degrees. And that is the first one that we have to calculate here. ABC is equals to 26 degrees. Then, what is the other one? After getting ACB, what else do you have to find? CAT. CAT. It is easier for us to find CAT now. Once you know the value of ABC to be 26, we want to find CAT. If you look at this point, this is a straight line. This is a straight line. And we have been told that angle in a straight line is equals to 180 degrees. Angle in a straight line is equals to 180 degrees. Therefore, angle, you can now say, take it whatever. This angle is 128. You can now say that 128 degrees plus, you know the value of this angle now, which is y, plus the value of this angle, CAT. CAT, everything must be equals to 180. That is the sum of angle in the straight line. This one is sum of angles in a straight line. Okay, this is a 128 plus y. What is our y? Our y is equals to 26 degrees plus CAT equals to 180. 152 degrees, that's by the time we added this one together, 128 plus 26 is 152 plus CAT equals to 180 degrees. CAT now will be 180 minus 1 minus what? 152. 180 minus 152. By the time we add to subtract it from this gives us 28 degrees. It gives us 28 degrees. That means CAT will be equals to, am I right? No, there's an error here. 128 plus 26 will give us 154. 154. 128 plus 26 gives us 154. This one should be 154. This one should be 26 degrees. This one will be 26 degrees. And that's our final answer. That's our final answer. By this will bring us to the end of our first segment of this particular lesson.